Hi, this is Mr. Shumway. This video clip describes some four-sided shapes. A quadrilateral has four sides. That's the only thing that is required, is that it have four sides. In GeoGebra, it shows you the lengths of line segments. So line segment from A to B has been labeled A, and it says it's 7.07 long, and it doesn't match any of the other lengths of the other sides. But it is a quadrilateral. It has four sides. This shape is what we call a parallelogram. It has two pairs of parallel sides. How do we know they're parallel? Well, going from A to B, I have to go over 1, 2, 3, 4, 5, 6, and down 2. Going from D to C, I have to go over 1, 2, 3, 4, 5, 6, and down 2. So they have the same slope. Going from D to A, I have to go up 1, 2, 3, 4 over 2. Going from C to B, I have to go up 1, 2, 3, 4 over 2. So those two pairs have the same slope. So they are parallel. They will never cross. It just turns out that there is also two pairs of sides that have the same length. Because they're parallel, they will create equal lengths for two of the pairs. I might just point out that this is a quadrilateral, so to call it quadrilateral is not wrong, but you try to be as specific as possible. It does have four sides, but it also has two sets of parallel sides, and so we would label this one as a parallelogram. This quadrilateral is a square. All four sides are of equal length. You can see they're all the same length. Also, each of the corners create a 90-degree angle. Now, in GeoGebra, we can measure the angle. Right here, we can say, well, let's measure the angle. We can go A to B to C. And it says, yeah, that's 90 degrees. I can go from B to C to D. That's 90 degrees. So if those two are 90, then that's enough to convince me that they all will be 90 degrees because they are all of equal length. But if you didn't know that, you could go off of the slope and show that the slopes are negative reciprocals of each other, and that would mean that the slope of A compared to B would be perpendicular. Let me show you. So going from A to B, I go down 2 over 5. So the slope there would be down 2 over 5. Well, going from B to C, I would go down 5, back 2. Well, that could be a negative divided by a negative is positive. So when the slopes are negative reciprocals, meaning one is negative and one is positive, and one is flipped over from the other, then those two are perpendicular, and you know that they are at 90 degrees to each other. There is another shape that has all four sides have the equal lengths, and that is a rhombus. The rhombus is not required to have 90-degree angles, and so this is an example of a rhombus. All of the sides are length 5. but the angles are not the same. So this one is a parallelogram, but more specifically, you would say it's a rhombus, which is a more specific type of parallelogram. A square is a rhombus, but square is more specific than rhombus because of the 90-degree requirement. Another quadrilateral that's specific is a kite. Like if I take this rhombus and move one of the points so that we have two pairs of equal lengths of sides that are right next to each other, like A and D are right next to each other. They have lengths of 3.61. B and C are next to each other, and they have lengths of 5. So they call that a kite. It looks like a kite, at least one type of kite. A trapezoid only has to have two parallel sides. So this bottom one and this top one are parallel to each other. The other sides don't necessarily need to be parallel. So this is actually a trapezoid. Typically you see shapes that look more like this, or maybe like that, and they call them trapezoids. But the main thing is that they have two parallel sides. So a square, for example, is a trapezoid, but you're supposed to be as specific as possible, and so you wouldn't call a square a trapezoid because you can be more specific because it has 4 parallel sides. Well, that makes it a parallelogram, but you can, it has 2 pairs of parallel sides, but you can be more specific because those 4 sides are all of equal length. But you can be more specific than that, even more specific than a rhombus, because you can call it a square because of the 90 degrees. So when you're categorizing these, try to be as specific as possible. So those are some of the basic 4-sided shapes.